Today on Capechi's Corner, we're going to prove triangles congruent, and we're going to take a second day to look at the HL theorem. In our first problem today, we're going to name a pair of overlapping triangles and which congruence methods proves the congruency. So if we look at the top here, we have two overlapping triangles. We have given information, and sometimes it's a little overwhelming to look at the triangles and the segments and the angles when the diagram is overlapping like that. So what I did down here at the bottom is I separated the triangles. So when we mark the diagram, we're actually going to mark in two spots. We're going to mark in the separated diagrams, and we're also going to mark in the overlapping triangles as well. So let's mark the given. It says xz is equal to yw. So if we do it on the bottom here, we have xz is congruent to yw. Now when we do it in the top overlapping triangles, you can see it gets a little tricky to see, but we are going to mark it. So I have xz is this big segment here is congruent to yw, which is here. Again, you can kind of see why that's difficult to work with alone. My next statement says angle x is congruent to angle y. Angle x is congruent to angle y. Mark that up top, x and y. And now I just need one more piece of congruency. So if I look at the triangles down here separated, it doesn't give me much of anything to work with because it's hard to see what is congruent. But if I look at, and again I can shade in what I'm looking at here. So this is one triangle right here in red, and my other triangle is going to be in blue here. And when I do that, I notice that both triangles include angle A right here. So what I'm going to do is I'm going to mark angle A as congruent. Angle A is the same in both triangles. So I'm going to mark angle congruent down here, my overlapping part. And I notice now that I do have congruency because I have angle, angle, side, and I have angle, angle, side. That side is not between the two angles. So I have angle, angle, side. We also know that if two angles of one triangle congruent to two angles of another triangle, that those third angles also have to be congruent, since each of those triangles have a sum of 180 degrees as their interior angles. So if I wanted to, I could also say angle, side, angle, although angle, angle, side is the more obvious choice. Let's take a look at our first proof for today. Segment EF is perpendicular to segment EG. Segment HG is perpendicular to segment EG. And then we have some given segments that are congruent. Segment EH is congruent to segment GF. And we're trying to prove that angle H is congruent to angle F. Now again, if we're trying to prove that angle H and angle F are congruent, we know that if I can prove that triangles are congruent, then I can state that those angles are congruent because of CP/CTC. So let's mark our diagram. Let's see what we have. I have EH is congruent to GF. Now I know that EF is perpendicular to EJ, and I also know that HG is perpendicular to EJ. So for now I'm going to mark my diagram. So I have EF is perpendicular to EJ, so there's a 90 degree here, and then HG is perpendicular to EJ, so it's 90 degrees there. Now again, whenever I see a right angle, I'm going to have to decide whether I'm going to use the HL theorem, because if I am, I have to make sure that I state that the angles are right and that they are also right triangles. So I notice that the other piece that's going to help me is this EG is reflexive. So I'm just going to, again, mark that diagram for now. And I am going to use HL theorem because I have a right angle and I have the hypotenuse and I have a leg. So now I need to make sure I set the proof up correctly. So now I first have to state that the angles are right angles. So I have angle HGE and angle FEG are right angles. And that is because of definition of perpendicular lines. Now that I stated the angles are right, I can state that the triangles are right triangles as well. So I have triangle HEG and triangle GEF are right triangles, and that is because of a definition of a right triangle. Now notice in this proof I don't have to state that these angles are congruent. because I'm using HL theorem. I just need to state that the angles are right so that I can then state that the triangles are right. Now I need to do my reflexive piece. So I have EG. Segment EG is congruent to itself, and that is because of reflexive. And now I'm ready to state that they're congruent. So I can say triangle HGE is congruent to triangle FEG, and that is because of the HL theorem. And I'm ready for my last statement. Angle H is congruent to angle F, and that is because of CPCTC. Our next proof gives us the information that KL is perpendicular to LA and segment KJ is perpendicular to segment JA. We also know that ray AK bisects angle LAJ, and we're trying to prove that segment LK is congruent to segment JK. So once again, if I'm trying to prove that a segments of the triangles are congruent, then I know if I get the triangles are congruent, I can use CPCTC. So when looking at our first given statement, the perpendicular lines, I have to decide what my next step is. Am I going to say that the lines are forming 90-degree angles, and I'm going to do that if I'm trying to prove congruency, or am I simply need to state that they're right angles, and I'm going to use that information if I'm trying to prove the triangle's congruent with HL theorem. So let's see what we have. I'm going to mark it first and kind of talk my way through this proof before I proceed in the written part. So I have KL is perpendicular to LA. So I know I have a right angle here, and I also know that KJ is perpendicular to JA, so I also know I have a right angle here. Now my other given statement tells me that ray AK bisects LAJ, so I know that this angle is congruent to that angle. And my last piece of information I have here is I see that KA is reflexive. So I have angle, angle, side in both, angle, angle, side. So in this case, even though I have a right angle, I am not going to use HL theorem. So let's get started from here. I'm just going to go for congruency. So I have to say that the measure of angle L is equal to 90, and the measure of angle J is equal to 90, and that is because of definition of perpendicular lines. Now if they are each equal to 90, I can say that they're equal to each other, and therefore they're also congruent. So I'm going to say the measure of angle L is equal to the measure of angle J, and that is because of substitution. And then I'm also going to state that these angles are congruent. Angle L is congruent to angle J. So now I'm going to work with my other given. Ray AK bisects angle LAJ, and that's given. And because of that, I can say angle 1 is congruent to angle 2, and that is because of definition of an angle bisector. Now from here I can do my reflexive piece. Segment KA is congruent to segment KA, and that's reflexive. Now I have what I need. I have angles that are congruent here, I have angles that are congruent here, and I have my side that's congruent there. So now I can state congruency. So I can state triangle LAK is congruent to triangle JAK, and that is because of angle, angle, side theorem. And because I've seen that the triangles are congruent, I can now do my last piece. So I can say segment LK is congruent to segment JK, and that is because of CPCTC. Now the big thing from this proof is that just because I have right angles doesn't necessarily mean that I'm going to use the HL theorem. In this case, I did not have a hypotenuse and a leg congruent. I just had the hypotenuse. So I had to look at those right angles as pieces to get congruency a different way.